So now moving on to the table and the box and whisker graph. So the table shows exact results and are easy to read and understand with clearly laid out columns and headings. The data can also be easily manipulated with the rank order and range, for example. So this means that while your data is in this form, it is easy to rank order. So it's easy to put in rank of highest to lowest, or no, lowest to highest, sorry. And then you can take the range from this. You can get the mean, the mode, the median. You can use you can take descriptive statistics from this data that can be helpful quite easily because it is laid out simply, whereas if it was laid out in a bar chart, for example, it would be harder to take those values. So that is a benefit. The disadvantage to a table is that it is less visually pleasing to present your data in this way because simply it is just because it does not show the immediate relationship between values. It doesn't show the immediate comparison between values either. So it is hard to see initially what the data is presenting, what the data is, and it's significant to each other. You have to look and sort of take in all the data to get that result. So the box and whisker graph. So here, so the box and whisker graph. So this is for systolic and diastolic blood pressure, and we can see two boxes with whiskers. Basically, that is the box and whisker diagram. Each for one of the topics. So I've only got two. I've got systolic and diastolic blood pressures. And the box and whisker graph is similar to the line graph, however it can show much more information. It also includes quartile ranges. So, for example, these are the whiskers coming off the box, and these show the extremities. So this lower extremity for systolic blood pressure was 100, and its upper extremity was 150 by the looks of it. And so these whiskers show the extremities of either the highest extremity or the lowest extremity. This line in the middle basically represents the median of the values, and then this is the upper quartile, and this is the lower quartile, and you can basically work out. So normal distribution, the Gaussian distribution curve basically means that there has to be even values on either side to form a bell-shaped curve. This basically means that the curve is symmetrical and the information on both sides is completely the same. So a normal distribution curve is symmetrical on either side, and a normal distribution curve, the values on either side account for the symmetrical bell-shaped curve. It states that 68% of the data in the curve needs to be between +1 and -1 of standard deviation, 98% needs to be within +2 and -2 of the standard deviation, and 99% needs to be within +3 and -3 of the standard deviation. This is the empirical rule and means that either side of the curve is equal and obviously normally distributed. The curve can be as tall as short, or as short, but as long as the curve is symmetrical, it means that it is normally distributed. Interpreting data from a normal distribution is simple as the data is presented clearly. Another word for normally distributed data might be parametric data, and non-parametric data is asymmetrical distribution curves, which is also known as a skewed distribution curve. So it doesn't have equal values on either side, causing a skewed distribution curve. Positive skew curves is when the tail faces the higher end on the chart, whereas a negative skew points to the lower end of the chart. Left skewed dataset, median and mode are greater than the mean, and it has a negative ending. And the right skewed dataset, the mean is greater than the median and mode, and it has a positive ending. So now moving on to outliers. An outlier is a value that does not closely share the same value as the other data. Outliers can skew results and make the final dataset unrepresentable of the values inside it. So outliers create distortion in data as they do not represent the other values in the data and therefore skew the results. Outliers and anomalies are values that have had external or internal factors affecting them, which were not the same as the other values, which means that the results come out differently. They need to be identified as outliers because otherwise they will be regarded as accurate results that will be included in the final data representation. And there are always ways to take out anomalies and outliers easily, however, to make sure the data does not become distorted or misrepresented by an outlier. So trimming and Windsorizing, these are the two main ways of basically clearing up the data and making sure that it is not skewed by a outlier. So trimming is basically where you just take off the outlier. So 2 would be considered too low, and 22 would be considered too high, and it would skew the data set. So instead of basically you're just trimming these numbers off the edge to get a sort of clean data set with no outliers. So Windsorizing, however, is basically instead of cutting these two numbers off, you will replace them with the next legitimate number in the chart. So, for example, 2 becomes 10 and 22 becomes 14. This way, you keep the same amount of data, but you're not disrupting it by having an outlier that is too high or too low. So, moving on to part 3, my assignment. This is descriptive statistics, so central tendencies, the mean, the median, and the mode. So starting with the mode. The mode is the value that occurs the most often, and this is found by viewing the dataset and seeing what value has appeared the most amount of times and the most frequent value. This is the mode. So the benefits to the mode, it can be determined graphically and is easy to initially spot and point out in the dataset. The mode can also be used in nominal data, whereas mean and median can't. And its limitations are if there are more than one modal value, basically if there are more than one value that has been frequented the same amount of times in that data set, then the mode has to become bimodal, so there has to be two modal values. And this could sometimes make the research more complex and harder to understand. Some data, such as continuous data, aren't likely to have a modal value because each value only will occur once, because it can only possibly occur once, so there can't be a modal value because everything happens once. It doesn't represent all the data in the set. Yeah, so it will only represent the most frequented number. So this might be an outlier, and therefore sometimes it can be vulnerable to being skewed or sort of tainted by an outlier. So moving on to the median. To find the median, the first step is to rank all of the values from highest to lowest. Once this is done, you need to find the middle value, which is done by a process of elimination. So you find the value that is laid out in the middle when the numerical values are laid out in a line. If there are two middle values, then you need to plus them together and then divide them by n, which is 2, which is how you would get the mean. So you've averaged out those two values to get the middle value, and then that is your median. And the benefits to a median are it's less affected by outliers and not as strongly influenced by skewed values. The limitations, however, is it's slow to calculate with large data sets, not ideal with small data sets, as it means that the median may not be a good representative. So if there are only 4 numbers in the data set and one of them's a massive number and one of them's a small number, the average of that number will not be representative of the whole data set if you have to average them out. Or if the middle number happens to be a high number, and there is 4 small values in that data set as well, and they're not being represented either because of the high value that is chosen as a median. So moving on to dispersion. So dispersion is the action or process of distributing data over a wide area. So the range, I'll talk about the range first. The range is a rank-ordered set of data with the highest value of data at the top and the smallest value at the bottom. you need to then subtract the smallest number from the highest number of value to get the range. There are some disadvantages and advantages to a range, however, as if the numbers in the set are mostly comprised of small values and one high number, this can mean the range won't be a good representative of the data in the set, which is what we've talked about previously. So now moving on to standard deviation. Standard deviation is defined by a quantity expressing by how much the members of a group differ from the mean value for the group. So this means that basically it is a value telling you how much your participants' values have differed from the mean of that group. So standard deviation needs an equation and process to find. The first step is to take the data set and find the mean. So we can see in this example above it is 72.28. We then take away the mean from the original scores to get the next set of values. After this, the values have to be squared. Once all these values are squared, the values have to be added all together. This value is then divided by the m value, which is the first column, and then the answer from this is squared. This is how you find standard deviation value in a data set. The standard deviation is used to show how values differ from the normative values of that set. So, yeah, this is just useful to see how your results are differing from each other, and how close or how far away they are from the mean values. And here I've got the equation, so I've shown where, because these columns are basically doing this equation for you. So this number is the process of doing this equation at the top, and n-1, this is 13. So that value is there, and this top number here is a process and sum of what we've been adding up here, and this is how you might process it if you are new to doing the standard deviation. So SD equals sum of score minus the average squared divided by n-1 squared equals the standard deviation. So SD equals 94.72. That was the top number I got. Divided by 13 squared equals 2.69. 2.69 is the standard deviation for this set of data. So moving on to the interquartile range. The interquartile range is another dispersion method that you might use, and it is basically measuring the middle 50% of your data set. So basically in descriptive statistics, the interquartile range, also known as the mid-spread or middle 50%, is a measure of statistical dispersion being equal to the difference between 75th and 25th percentiles, or upper and lower quartiles. So this is the lower quartiles here, lower quarter, and this is the upper quarter. And basically you're measuring between Q3 and Q1, the middle 50% of your data you're going to be measuring, and you do this by finding the mean for the whole data set, and then basically dividing that by 4 to get your quartile range, and then you would from getting the median for the whole set, you would then split the data into halves, like this is done here. So it's got five values this side, 5 values this side, and you then find the median value for each of these, and basically after finding the median values for each of these quarters, then you find the range, and that is the interquartile range. That's the interquartile range for your whole data set, and that's the range between the middle 50% of your data.